good day. Welcome to Lab Talk. This is a series of expert tips to help you make the most of our products in your lab and help you advance toward your discoveries in the most efficient way. So today, my name is Angela Carnwright, by the way. Today, we're going to be talking a little bit about the compatibility of plasticware. Very exciting today, this talk, because it is something that everybody uses in the lab. There's an awful lot of different types of plasticware. There's lots of different chemicals that we're putting into those plastic bottles and tubes. We want to make sure that we're setting you off on the right track and giving you some guidance toward that. I would like to introduce our speaker today, Mr. Mike Montanez. He is our Senior Commercial Manager for the Laboratory Plastics Essentials business here at Thermo Fisher Scientific, and he has some great content to share with us. And so over to you, Mike.
Thanks, Angela. No, I appreciate you having me back on, and welcome everyone. So as Angela said, my name is Mike Montanez. Happy to be with everyone here today, and I appreciate everyone joining today's discussion and to talk about chemical compatibility with lab plastics. So, choosing the right plastic material for your specific application is absolutely critical to ensure your success. It is important to remember that not all plastics are created equal, and using subpar material in the lab can pose a real threat to your work. So some common plastics and additives may contain extractables that can compromise your research. So let's take a look at seeing what are the right plastics that meet the rigorous demands of your scientific work. So selecting the right plastic material for specific application is critical. Not only, not all lab plastics are designed to withstand the high demand of the lab. So polymers are a large molecule made up of repeating subunits called monomers. Plastics are synthetic polymers that can be molded or shaped into various forms and are widely used in numerous applications due to their versatility and durability. Now, a common resin, polyethylene, consists of ethylene monomers. Polymerization is a process linking those monomers in a long chain that occurs with heat, pressure, and when a catalyst is also combined to make the three. Chemical compatibility refers to the ability of lab plastics to resist chemical degradation or interaction when exposed to specific chemicals. Chemical compatibility is vital to ensure results in experiments for your lab, as well as safety when using lab plastics. So there are three things to consider here when selecting the correct plastic. One is selecting a compatible lab plastic. Two is going to be practicing proper handling and storage. And three, conducting necessary testing to ensure integrity and property protection. Next slide, please. Okay, so we're going to take a look at 6 areas to focus on. First, let's take a look at affecting chemical compatibility. So there are several factors that influence chemical compatibility. These are including chemical compositions. Different plastics have varying resistance to specific chemicals. Concentration. Higher concentration of chemicals may pose a greater risk of incompatibility. Next would be temperature. Evaluating temperatures can accelerate chemical reactions and increase the likelihood of interactions. Last is exposure time. So prolonged exposure to chemicals can cause degradation or damage to lab plastics. Next thing to consider, it's going to be incompatibility. So using incompatible chemicals to lab plastics can lead to various consequences, and those might be degradation. Lab plastics may break down, become brittle, develop cracks. I'm sure everyone's seen that from time to time, walking through, seeing really aged labware in specific areas. Next is leaching, and that would be chemicals leaching into samples, and that's going to affect your results downstream as you continue your work. Next would be contamination. That's incompatible chemicals can contain samples, leading to inaccurate data, which causes more extra work and causes a lot of issues. Next is reduced performance. Lab plastics may lose their intended properties or functionalities, which is extremely critical. And last would be looking at safety hazards. Incompatible plastics can pose a risk to lab personnel, and that's including chemical spills or reaction, which nobody particularly wants and something we avoid right at all costs. So next, we'll look at common plastics and their compatibility. So different lab plastics exhibit varying levels of chemical compatibility. Some commonly used lab plastics may include polypropylene, known for its excellent chemical resistance and a wide range of substances. Polyethylene offers a good chemical resistance, but may be less resistant to certain solvents. Polycarbonate offers a high transparency with good chemical resistance, but can be affected by some solvents. And high density polyethylene, it's a durable and versatile thermoplastic polymer. It's known for its high standard strength to density ratio. It's very resistant to chemicals, moisture, and impact. So next, let's take a look at selecting the compatible lab plastics. And this has helped to ensure chemical compatibility. First, we'd recommend consult a chemical compatibility chart. These can be provided by manufacturers or some other reputable sources. You can get this from the table to see what chemical might be compatible with certain plastics. Follow the guidelines and recommendations from your lab plastic manufacturer. And often we do a lot of testing here, and you see other manufacturers, and it's not often we do a lot of testing here to ensure that the proper plastics are very compatible with certain chemicals. And last would be seek advice from experts or experienced colleagues. This is a good opportunity to reach out to others in your lab to say, hey, what have you done? And what plastic have you used using these certain chemicals? And that will help ensure your work is not only accurate and effective, but you're not having any safety issues down the road. The next thing we recommend is testing the chemical compatibility. Testing can be performed to take a look at what compatible plastics are compatible with certain chemicals outside of the chart. So what are some areas you can do to test? And some first would be an immersion test. And this would involve exposing lab plastics to chemicals for a defined period of time, and then taking a look at to see if there's any sign of degradation to the plastics themselves. The next would be an exposure test. And subjects, we take a look at lab plastics to the actual experiment conditions to evaluate performance, kind of replication in first test run to make sure that there's going to be no leachables, or the plastic may not be in turn broken down and may cause some safety issues. The last would be compatibility tests, and is that providing a pre-selected chemical to test against different lab plastics. And there's also kits available for this as well. Then lastly would be lab safety and chemical compatibility. So chemical compatibility directly impacts lab safety. Using a compatible lab plastics reduces the risk of accident, spills, and chemical reaction. And the last point, ensuring chemical compatibility protects lab personnel from potential harm and maintains a safe work environment. So you're seeing a lot of recurring themes here, right? One, not only is employees and personnel safety inherited, but we're also making sure that our work and the bench work themselves, experiments, results are not impacted by any potential compatibility nuances. So to ensure chemical compatibility in lab setting, consider the following best practices. One, regularly review your chemical compatibility guidelines provided by lab plastic manufacturers. Two, properly label your plastics to avoid confusion and prevent unintended chemical reactions. I'm sure everyone's seen walking through lab spaces, just bottles and plastics everywhere, and that can be caused quite confusing at a quick glance without some further investigation. Last, provide ongoing training to lab personnel on importance of chemical compatibility and safe handling practices. So we can go to the summary slide. Understanding and ensuring chemical compatibility for lab plastics is critical for reliable experiment results and maintaining safe laboratory environment and working conditions. So by selecting compatible lab plastics, following proper handling and storage practices, and testing when necessary, labs can ensure the research integrity and their personnel is safe and also protected. So we've got a lot of information available, resources at your fingertips. Compatibility charts are also available. These links were provided here. We've got a great learning center available for folks to reference if they have any questions. If you have any questions too, you can reach out to myself that's on this particular or your local representative to help find the right bottle that is compatible with a particular chemical that you're looking for.
Awesome. Awesome. And we do have, as you see here, the resources, the selection. We have help. We have Mike, but we also have a whole team of people out in the field that are super happy to help you out. So if you need help reaching out to your local rep, there is a post-event survey today. Definitely fill that out. We have a certificate of completion available for you if you need to show it for your continuing education. And we also have the opportunity to request a meeting with your local specialist. So if you're not sure where to start, check the box that you're open to meet with one of our team members, and we'll make sure to match you up with your local contact. We have a lot of great experience on our team, and certainly happy to help you and come right by the lab. That concludes our session. Mike, thank you so much for that awesome, great overview, a good reminder of some tips on how to get started thinking about chemical compatibility in our plasticware. Lots more resources available. Let us know if you want any other topics in the post-event survey, and thank you all for joining today. We will be taking a break from Lab Talk for the summer, so we will be back in September. Really excited to offer some really great topics around the biopharma world. So it could be like the GMP environment. We want to help you understand how to really scale up and effectively create and impact science at that level. So we're going to give you some great tips in the fall. Please join us, and thank you again for joining.
Enjoy your summer, everyone. Thank you.